Okay, I'm going to do something here on number 13 that's not going to work. So just watch what happens here, and I'll show you what's going on here in just a minute. So let's just pretend we move those two things over there like we had done. So I'm going to start with iron. So right there's two of them in that term. There's no iron here. There's no iron there, and there's one iron here, but it would have been moved over, so it would be a -1 over there, and it's equal to 0. Okay, and then let's go with sodium. Got one package of 3, so there's 3 of them. I've got no sodium in any of that. I've got one sodium sitting right there, it'd be on that side, so it's -1, and there's no sodium there. Oxygen, got 4 packages 3 times, so there's 12 sitting there. I've got 3 oxygens 2 times, so there's 6. I've got 4 oxygens over here would be -4, and here I've got 3 oxygens 3 times, so there'd be 9 on the other side. And then Ba, what is that? Basalt maybe? I don't know. None there. Got 1 Ba there. Got 1 there that would be on the other side, and I've got none there. And is that everything? No, we've got a nitrogen still. 0 nitrogens. There's a nitrogen twice. No nitrogens there, but there's a nitrogen 3 times, equal to 0. Okay, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Let's get in this 5 by 5 here. Okay, so I've got a 2, 0, 0, -1, 0, 3, 0, -1, 0, 0, 12, 6, -4, -9, 0, 0, 1, -1, 0, 0, 0, 2, 0, -3, and 0. Okay, I've got it in there. Let's take a look at what's happening to that. So I would like the reduced row echelon form of matrix A. Okay, let's see here. So I've got a bunch of zeros there and a bunch of zeros there. So let me jot down just what I have here so I can have some paper to deal with it. So I've got 1, 0, 0, -1/2, 0. I've got 0, 1, 0, -3 halves, 0, 0, 0, 1, -3 halves, 0. And then the last 2 columns are zeros. Okay, we can just ignore those then. Look, right here's the reduced row echelon diagonal. So I had, here was A, B, C, and D, and then the answer. So this is A, B, C, D, and then the answer. Okay, so I have something right here. So I have C minus 3 halves D equals 0. Okay, so that would be the same as C equals 3 halves D. Here I've got, so there's 1. Here I've got B minus 3 halves D equals 0. So that's B equals 3 halves D. And here I've got A. A equals A minus a half D equals 0. So A is equal to half of D. Okay, so if I were to write all this stuff out then, so the A is a half D, the B was 3 halves D, the C is 3 halves D, and then D. Okay, so the problem that I thought we were going to have doesn't seem to be occurring here. So it looks like it can make D 2. So if D is 2 there, that's going to be 3. If D is 2 there, that's going to be 3. And if D is 2 there, that's going to be 1. So it looks like I've got a 1 of these. So I've got 1 Fe to SO4, and then 3 of these BaNO3. and that goes to 3 BaSO4 and 2 FeNO3. Okay, not really fitting it all on there very well. Okay, so to check that, on this side now, there's 3 of the BAs and there's 3 of the BAs. So that's good. I guess I could just go in this order. How about the iron? Okay, there's 2, and that's all. So this side has 2. Does this side have 2? Right there's 2 irons only, so the iron's good. Oxygen. There's 12, and there's 6 more, but there's 3 of them. So there's 6 3 times, so that's 18. And then here was 12. So this side has 30 oxygens. Okay, let's see here. So there's 4, but we have 3 of them. So that's giving us 12. And here's 9, but we have 2 of them. Okay, so that side. So there's 30 oxygens both. How about N? Let's see, no N's there. So there's 2 N's, but we have 3 packages of them, so that's 6. Over here, the nitrogen, there's 3 nitrogens, and there's 2 packages, so there's 6. And we're left with sulfur. There's 3, and none here, so there's only 3. What about sulfur over here? There's 1, but we have it 3 times. Okay, so that worked out. So what I want to show you is, do we really have to have this set equal to 0? Okay, so I thought it was actually going to crash, but it didn't crash. Both of these bottom ones, I thought only one of them was going to go away, and it was not going to work out, but it made the bottom 2 go away, and everything was good. So we can still keep doing what we were doing. However, now I want to show you something. You don't actually have to set these equal to 0. They can stay what they are. They can stay in the same place, because really it's not a math equation. We really would never move this over and then it turns into nothing. That's kind of what we're saying when we move it equal to 0. Well, chemistry is never going to have a combination that turns into nothing. So we really can just leave them the way they are. So let's do this one that way now. So we've got Fe. Okay, well there's 2. There's none. Now since I'm not moving them, I'm just going to call this Fe1, and I'm not going to make it equal to anything. These 2 are equal to those 2, basically. Okay, the sulfur. Well, there's 3. There's none here. There's 1, and there's none there. Oxygen. There's 4 3 times, so that's 12. There's 3 2 times, so that's 6. There's 4, and there's 9. What else we have? Ba, maybe basalt. There's 1 right there, and there's 1 right there. And then we still have nitrogen to deal with. No nitrogens. There's 1 set twice. No nitrogens. And there's 1 set 3 times. Okay, now we have 1, 2, 3, 4, 5, 5 by 4. Okay, so I'm going to put in the 5 by 4. So last time it was a 5 by 5. Okay, 2, got that one in. 0, 0, that's now a 1. 3, 0, that's a positive 1, 0. 12, 6, need that to be positive 4 and positive 9. 0, 1, 1, 0. 0, 2, 0, now make that a positive 3. Okay, so there's the 5 by 4 without the 0 column now. Let's take a look at the reduced row echelon form of that one. Okay, We have something wrong now. So one of the things that happens is if you end up with more 1, 2, 3, 4, 5, and then it only has 4 over, a 5 by 4, that means we have 4 equations and 5, let's see, what do we have? We have 5 equations and 4 unknowns. Okay, that's not going to be able to go to row echelon form. I should have done it. This one's the one that doesn't work. So if you end up with the first number being bigger than the second number, it's not going to work. So if we end up with the first one being bigger than the second one, then we have to add in this extra row of zeros in order for it to get the diagonal set. Okay, now if you have a 5 by 4 and you just want this extra row of zeros, all you've got to do is make it a 5 by 5. And look, by default, it adds an extra column of just zeros. So now we're where we were the way I had it set up in the first place. So there goes what I had over here. So there's the matrix over there, and it turned out to be this one. So now we have what we did at the very beginning. Okay. Let's do number 14. So we already did this one. You can just answer this one as 1, 3, 3, 2. Now really I don't want you to answer it like that. We need to put it up here so there's one of those. So really the answer is one of those, 3 of these, 3 of these, and 2 of those things. That's what chemistry is really looking for now. So we're using our calculator to help us find those, but the actual answer is to put those values up there. Okay, let's see how 14 works out. All right, so I'm not going to put the extra column of zeros unless I need it. So I've got some potassiums here. So we've got 4 of them there, 4 of them there, and 2 of them there. And I've got oxygens. 6 of them here, 0 of them here, and 4 of them here. Now this looks like it might be easy, but if we were trying to do that by hand, it's hard to get 6 and 4 to match up. Well, actually, since the oxygens are also 6 and 4, this one probably wouldn't be that hard to do it by hand. But now that we have such a fast way to deal with it, let's just put in the 2 by 3. Okay. 2 by 3, and so now it goes so fast. We've done all the thinking, now we just pretty much do the mechanics. Okay, fractions are almost always easier to deal with here. Okay, so there we have it. So right here, remember so I'll jot it down up here. So what this has given us is 1, 0, 2/3, and then 0, 1, negative 1/6. Here's the reduced echelon form. This was A, B, C. Now see, we didn't make it equal to anything. So that was the A, that's the B, and that's the C. So look what I've got right here. I've got, let's see. We could think about it as it's equal to 0, but here is the relationship. Now, if we're not going to get too hung up on negatives, then everything is okay. I can say, really what this is saying is B minus 1/6 C is 0. Okay, so B is 1/6 of C. And then this one is saying A plus 2/3 of C equals 0. So A is negative 2/3 of C. Now that negative right there sometimes is an issue. But what we're going to do is we're going to treat that as a negative. Later on a harder one, that negative is going to matter, and I'll show you how it matters. But right now, it doesn't matter. So, and I'll show you why. We just want the absolute values of those. So here's our little answer set. We've got negative 2/3 of C. The second one is 1/6 of C, and the third one is just C. So if I let C be 6, this one now is 1. And if this is a 6, 2/3 times 6, the 3 will cancel that down, and this will become a -4. Now, it's the absolute value of all of those. So really now, at the end, it's the absolute value of that. So it's going to be 416. So I have 4 of these, 1 of these, and 6 of those. So there's our answer set. Now for each of these, I do want you to go back and check it. So I'm going to go with the potassiums. See, on this side, I've got 4 packages of 4. So this side has 16. There's 6 times 2 is 12, so there's 12 of them and 4 more, so the potassiums are 16 each. And then the oxygens. I've got 4 sets of 6, so the oxygens on this side is 24. And here I've got 6 sets of 4, so the oxygens on that side are 24. So we have it, we have a check. 15. Now we can go pretty fast, I think, I hope. So I've got potassium, 4 there, 0 there, 1 there. There's 1 P. Oxygen. Okay, I've got 10 here, 1 here, and 4 here. And then hydrogen. No hydrogens there, 2 hydrogens there, and 3 hydrogens there. Okay, now we can just go fast. Second matrix, edit. I have a 3 by 3. I may or may not need that extra set of zeros. On a 3 by 3, let's take a look and see what we have here. So 3 by 3, we've got 4, 0, 1, 10, 1, 4, 0, 2, 3. Reduce that thing down as some fractions. Okay, so that one turned out nicely. So I've got 1, 0, 2/3. And I've got 0, 1, -1/6. Okay, so there's the reduced row. So here's 1b minus 1/6 c equals 0. And up here I have a plus 2/3 c equals 0. So b is 1/6, a is 2/3. -2/3. So the a is -2/3 c, the b is 1/6 c, and then c. I'm just going to pick a whole number that makes all of them whole numbers. So it looks like 6 again. So 6 in there makes that one 1. If I stick a 6 in there, that gives me a -2, and I want the absolute value of that. So this is a 216. I need 2 of those, 1 of those, and 6 of these. That's how we would answer them. Okay, checking. I have some potassium. Right there is 8. So there's 8 potassium on this side. This side, looks like I only have 6. That's not good. This potassium, there's 6 of them. Okay, it doesn't look like we got that thing balanced. Let's see what else happens. What else did we have? Oxygens. I have 2 sets of 10 for 20. And here I have 6 sets of 4 for 24. Things are not looking good. And then hydrogen. Here I have 1 package of 2. And here I have 6 packages of 3. Okay, that's definitely a problem.